we do number 10?
Yes, let's do number 10. So absolute max at 2, absolute min at 5 and 4. At 5, 4. At 5, okay, sorry. 4 is a critical number, but there is no local max or minimum there. No local max min. You chose
critical number?
Yes, you chose the one that we cannot really do before I explain what the critical number is. That's fine. That was my next step anyway. So let's talk about critical numbers. We're going to come back to this problem after we discuss critical numbers. Okay. So what is a critical number? A critical number or critical numbers of a function come from two possible sources. Both have to be checked. Okay. Source number 1, f prime of x equals 0. Source number 2, f prime of x equals undefined at x values where f of x is defined. I'll explain all of this. I just have to write it first so you have it in writing. X values where f of x is defined. Okay. I was thinking to say one more thing about your question. A function can have a local max or min, but not have a tangent at that point. I wanted to answer fully. See, let me go back. I was just, okay. So for example, here, this is a relative max and an absolute max. But at this point, the derivative does not exist because it has a vertical tangent. Or if you want, it's a cusp, inverted cusp. Okay? So your question was very good about this one. Where is the tangent? Well, the tangent on this is on this side. The tangent on this is on this side. At this particular point, there is no tangent, unique tangent, because the function is not continuous, it's not differentiable. Same thing here. The function is continuous, but it's not differentiable. It has an absolute and a local or relative max, but it's not differentiable at that point. So again, functions may have max min, but not a derivative at that point. It was a very good question. It was the best question so far.
Okay.
Very good question. Thank you. I appreciate that. Okay. Coming back to our discussion, because that was my next step anyway. As I said, critical numbers. Critical numbers are important numbers of a function. They can come from two possible sources. A function can have a critical number coming or critical numbers coming from this as well as from this, or just from this condition, or just from this condition, or none at all. So everything is possible. We may find critical numbers or points, in other words, coming from solving this equation, also from coming from this condition, or from the top, or from the bottom, or from none of the above. Now, before we go into further details, why? Why do I need critical numbers? Why do I need to look for critical numbers? Why critical numbers? Why on earth will I need that? Well, I need that because only critical numbers turn, or may, right? So I'm going to put may turn into max min. In other words, what I'm saying here is, let's spell it out. If there are no critical numbers, immediately we conclude no max min. Guaranteed. If we find critical numbers, does that mean that there is a max min? No. No. Maybe is the correct answer. If we find critical numbers, they may turn into max min. But if we don't have any critical numbers, we know for sure there is no max min. So that is the reason why we're looking for critical numbers. We will know immediately, if we don't find critical numbers, we will know immediately that we will not find any max, any min. If we do, one more time, if we do find critical numbers, there is no guarantee. We have to further investigate. Further investigate. And I'll show you how. So if we find critical numbers, we will further investigate whether they turn into max min. There is no guarantee. Okay. Now, this problem says 4 is a critical number. In other words, either the derivative is 0 or the derivative is undefined. What does this mean? Okay, back to our graph. I'm going to save this. I really like it. I'm going to use it again. So, for example, here, the derivative is undefined. The function exists. The derivative is undefined at r. The function exists, and it has a relative max. So this is a critical number. Coming from which source? Coming from the second source, f prime being undefined. So something like this. This r is a critical number, the derivative is undefined, and it turns out that this critical number r, x equals r, is turning into a relative max. And it's coming from the second source because the derivative is undefined. Okay, so before we choose functions, because we picked this problem, so let's work on this problem first after we did the analysis for critical numbers, and then we'll open the discussion for any, because we have to study critical numbers a lot. We're going to spend some time on this. I'm looking here at the time. I'm fine, 7 minutes. That's fine. Okay, so let's analyze this. I'm going to copy it here, so I can put that page away. So absolute max at 2, absolute min at 5, and 4 is a critical number, but no local max, they say, or min. Okay, so let's see how we analyze this. So you know me, I like to summarize everything in a table. So the absolute maximum, so this is negative infinity, 0 is somewhere in the middle, and infinity. So absolute maximum at 2. Okay, absolute maximum. By absolute maximum, remember what we just discussed. For a function to have an absolute max or a max or relative max, if it's an absolute max, if it's not at the endpoint of the interval, is also a relative. But if it's at the endpoint of the interval, oh, sorry. It says on 1, 5. Sorry. 1, 5. Just forgot. They did say that. We're only discussing 1, 5. So this is not at the endpoint of the interval. So this must be a relative as well. So as we discussed, an absolute max or a relative max, the function has to increase, has to have, in other words, a positive slope, and then has to reach a 0 slope, and then it has to continue with a negative slope. Okay, so this is the absolute max, and it has to be a relative because it's not at 5 and it's not at 1. So we took care of that. Absolute minimum at 5, we know that absolute minimum here cannot be a relative because this is the endpoint. Okay, and now at 4, okay, they squeezed in here 4. Okay, fine. 4 is a critical number, but it's not a local max or a local min. So let's see how we do that. Perfect. So let's graph. 1, 2, 3, 4, 5, between 1 and 5. They want us to, they didn't say anything about 1. They don't have to say anything about 0. I just always like to put 0 in the table. They said that at x equals 2, it's a max, absolute max. So at x equals 2, oh, it doesn't even belong in there because it's 1 to 5. So it's right here, but I don't care to put it in at all, of course. So at 1, we can decide what we want to do, but at 2, there is an absolute max. So whatever we do, this cannot be higher than that. No other value can be higher than the value at 2. At 5, there is no other value smaller than this. It can be positive or negative. It doesn't matter what you would like to do. Okay. And now the only discussion is at 4, where they say it is a critical number, but it's not a local max or a local min. So the derivative is undefined. So at 4, f prime of x is undefined. And we can create a vertical asymptote. But the function has to be defined. So for f prime being undefined, we have to make sure that f prime of 4 is undefined, but f of 4 is defined. So that has to exist. So I'm going to do this as a full point. So this is the absolute max. This is the absolute max, and this is whatever. And then we start here, and the absolute minimum. Full point, open point.
Could it also flatten to a slope of 0 before descending again?
So you wanted to start from here?
So if it at 4 it descends, it flattens out to an f prime, like a slope of 0, the tangent line slope of 0, and then it descends after
Yes,
that.
yes,
and that way it wouldn't be a relative.
Yes, we can do this.
Yeah.
Yes, that's fine. If that's what you want to do, that's fine. We can correct it here and do that.
No, I just wanted to.
So that's another. No, I just wanted to show another option. So this is a second option. Still, the absolute minimum is this point. The point exists. The function has to exist at that point. I even like that more than my suggestion. Awesome. I like that more. Good. Perfect. Awesome. Even better. Now, I would like to go back to our discussion of critical numbers. So, sketch the graph. No, we're not ready to sketch any graph. So we don't even think about any of this. We come back to it. We are not ready. Find the critical numbers. Yes, this is what is our next step. So we can choose anything from 29 to 48. We want to find critical numbers of the function.
Let's do number 29.
Number 29. So let's start with number 29. Perfect. 29, they have f of x equals 3x squared plus x minus 2. Perfect. Now, because we identify this function as being, can anyone tell us what type of function this is?
Quadratic.
Yes, polynomial in general. Perfect. Because it's polynomial, we do not need to look at the second option, but I will write it because this is correct. So we should always think in these terms. 1, f prime of x equals 0. And number 2, f prime of x equals undefined. We know that this is not possible for polynomials because the first derivative, can anyone give us the first derivative for this function?
6x plus 1?
Yes. This will never be undefined. It's not possible. So this second option for polynomials is non-existent. What about the first one? Well, 6x plus 1 equals 0, so x equals?
Negative 1/6.
Very good. This is definitely a critical number. Now, I'm adding one thing to this question. I know it's not there yet, but I don't want to wait. I would like to discuss it now. The next question is, so number 1, find number A, part A. Find critical numbers, if they exist, of course. Part B, x equals negative 1/6 gives a max, min, or none of the above. What does it give? Does this represent a max or min or not? I don't know. Here's how we create the analysis. Okay. Here's one option. Critical number negative 1/6. And the first derivative does this. Because it's 0. We know that. The first derivative was 0. Or the first derivative does this. Or the first derivative does this. Or the first derivative does this. There is no other option. These are all possible options. Okay, let's analyze the first one. If we find the critical number as negative 1/6, and the derivative is negative on this side, 0, and then positive, what does x equals negative 1/6 give? Or what does it represent for the function? The first derivative, negative slope, 0 slope, positive slope.
A local or absolute min.
Excellent. So this is a local min. Forget about this one. We analyze the next one. What if we find a critical number negative 1/6 where the derivative is 0, but then I find positive slope, 0 slope, and negative slope? What will negative 1/6, of course, comma f of negative 1/6, what will that represent?
A max.
Perfect. Forget about the first two options. Let's discuss the third one. What if we find a critical number as being negative 1/6, the derivative is 0, and then we find this. Positive, 0 slope at that point, and then positive. What type of point is this?
Nothing.
Absolutely. In other words, I should say no max or min. Good. Last option. We find that this is a critical number, the derivative is 0, and we find this, a negative derivative, a 0 derivative, and a negative derivative, which is very possible. What type of point is this?
Same.
Yes, nothing. That's it. This is called the first derivative test. Okay, so once we have the critical number, we don't know if this gives a max or a min or nothing. We do the analysis. So the analysis is, why I said 1 is because we got 0. The second option is identical with this, but we get undefined. I'm going to put it in parentheses. So 2 is undefined with a different color in parentheses. They are identical. Identical all. The answer is the same. So one possibility is I find a critical number when the first derivative is 0. Or I find a critical number when the first derivative is undefined, but the function is defined there. Okay, so all these possibilities are identical, and there are only 4. You can't find anything else. Either the first derivative changes sign from negative to positive to get local minimum, or changes sign from positive to negative to get a local max, or if it does not change sign, it doesn't mean anything. So it's none. If it changes sign from negative to positive, it's a minimum. If it changes sign from positive to negative, it's a maximum. If it does not change sign, even if we found critical number or critical numbers, if the first derivative does not change sign, this number will not give a max or a min. It is a must for the derivative to change sign for max min. For min in this way, for max in this way. So, because we want to finish this analysis now about this point, although this particular problem at this stage is not asking us to determine that.